This video is on quadratic applications, specifically projectile problems. These are word problems where we apply quadratic equations into actual problems in real life. These are specifically on projectiles, so things that are going up into the air and then coming back down, like rockets or throwing something. So we want to make sure we understand the situation that's happening, and then to understand what the question is asking. And when we want to draw a picture of this, because this is more real world, this is a real world situation, you don't want to necessarily look at the entire graph of the quadratic, because we know parabolas will go on forever up forever to infinity, or they might go down to negative infinity forever. But we know in real life you can't go on forever. So when we draw a picture, we want to make sure our picture represents the situation and not just the quadratic itself. So this first problem, it says a relief package is released from a helicopter at 1,600 feet. So the height of the package can be modeled by the equation h equals negative 16t squared plus 1,600. So we can see that the 1,600 is actually where it started from. And then it says where h is the height of the package in feet and t is the time in seconds. So the pilot wants to know how long it will take for the package to hit the ground. So again, let's just draw a picture real quick. So since we're dealing with height and time, we know that we can't have negative time. So when we draw a picture of this, our y-axis, so this is technically our y, and this is technically our x. So our y is our height. So if we're focusing on the height, we know we can't go underneath the ground. So we know it should only go to 0 down here. And then for time, we also can't go into the negative time, so we really want to focus on the first quadrant. So our time is our x-axis, and then our height is our y-axis. So we know it's starting at 1,600 feet. So this is where the helicopter is, so this is 1,600 feet. I'm going to write out 1,600 feet. And then we know that it's dropping, and it's going to land on the ground. Now, because it's a helicopter and helicopters don't stay stationary, it will be moving. So when it drops, it won't go straight down because it's being dropped from a height of 1,600 feet. It's going to move some. It might not move a lot, but it will move. So we know that our path of our package that's being dropped will actually come down from the 1,600. And because we know it's the shape of a parabola, it should end up going down and curving some until it hits the ground. We know that the package won't go underneath the ground because it's going to land. So this is our little package. So I'm just going to draw a little present here. So it's going to hit the ground. So we have a picture of this that represents our situation. It's starting at 1,600 feet and it's going down. So we got to remember what the question is actually asking. The pilot wants to know how long. So we want time, which again is the x value. We want to know the x value for the package to hit the ground. Well, the height is the ground. So when it's on the ground, the height is actually 0. So it says write the equation that you're trying to solve. So we want the ground. So here's our original equation. If it's on the ground, then our height is supposed to be 0. So it's supposed to be 0 equals, because we know the height, the negative 16t squared, because that's what we want to know is the time. So that means we don't have t, so we have to solve for that. Negative 16t squared plus 1,600. So all we're doing is just finding the x-intercept. So we just want to solve this by either factoring, complete the square, quadratic formula, square roots, whatever works. So we're going to do this by hand. If we understand the best method to use, we only have one letter written in this entire problem, that t. So the best method to use here is to just solve by square roots. So what we're going to do is get everything away from the t. So if we are to solve this by square roots, I'm going to have negative 16t squared plus 1,600 is equal to 0. We're going to subtract the 1,600, so it's negative 16t squared equals negative 1,600. We're going to divide by that negative 16, so we have t squared is equal to a positive just 100. And then we take the square root. So when we take the square root of this, it'll be t equals plus or minus. The square root of 100 is 10. So we really have two answers, which are t equals a positive 10 and t equals a negative 10. Now, it's quadratic, so you should still have two answers, but again, this is real world, so which answer actually makes sense to the problem? If it's trying to drop and it's hitting the ground, we cannot have a negative time. So again, the question is, how long will it take for the package to hit the ground? T is in seconds, so the package takes 10 seconds to hit the ground. The package takes 10 seconds to hit the ground. Now you should always make sure your answer makes sense. It's dropping from 1,600 feet, and so taking 10 seconds is not that long of a time. So if it were to have taken an hour, that would definitely be way too long for it to drop. So it's coming from 1,600 feet, which isn't even a mile up in the air. So dropping and only taking 10 seconds is not that long, so that actually makes sense for it to hit the ground. So 10 seconds to hit the ground would be our correct answer. So we wrote it in a complete sentence because we want to make sure that when we write our answer, that it actually makes sense. Because if you're writing it in a sentence, you're more likely to read it as does it make sense or not. This next problem says the height of a flare fired from the deck of a ship in distress can be modeled by h equals negative 16t squared plus 104t plus 56, where h is the height of the flare above water and t is the time in seconds. Find the time it takes the flare to reach its maximum height. So let's draw a picture again. So we're dealing with height and time. So we know the height, it can go up and it can go above water. It can go below water, but it's a flare. So it's probably not going to go underneath the water. So our height should go to the axis, and we can't have negative time. So again, we should just be focusing on quadrant 1. So we have time and height. Now, the flare is being fired from the deck of a ship. Now the ship is not, the top of the ship is not on the water. So the top of the ship would be above the water. And we have the y-intercept is actually at 56. So we know that the ship has to be at least to here. So 56, we know it's above water. So this is 56 feet. We know that's above water. And then the flare is being fired. So the way a flare goes, it goes up into the air so people can see it, and then it will come back down. So the flight of the flare goes up, and then it comes back down until it hits the water. So we have the picture of the flare. So let's make sure we understand what the question is asking. It says find the time it takes. So find the time. We want the x value. The x value. It takes the flare to reach its maximum height. So the maximum height would be somewhere up here. This is what our question is asking. When does it hit that? So it's focusing on the maximum, which we know is our vertex. Maximum just means vertex. So that's an x, y coordinate. So we have the AOS and then the y value of the vertex. The time is the x-axis, so we actually just want the x value, which is the AOS. So we want to find the AOS, which is x equals negative b over 2a. That's all we're finding. So let's answer the question. Our x value is equal to negative b, which is that positive 104, over 2a, which is negative 16. So we have negative 104 divided by negative 32. So negative 104 divided by negative 32 is equal to positive 3 25 hundredths. So what that means is that it takes the flare, this is in seconds because this is our time, 3 3.25 seconds to reach maximum height. So after it's been shot, it'll take 3.25 seconds to get up to its maximum, and then it'll start coming back down. So it doesn't take long for it to get up to the maximum. So this answer would make sense. It takes the flare 3.25 seconds to reach its maximum height, because all we're doing is finding the time, which on your vertex is just your axis of symmetry. This next question says the height of a rocket is being launched upward from a 160-foot cliff. So we know it's already at 160 foot, and then it's launching upwards. Now rockets will come back down. It's modeled by the equation h equals negative 16t squared plus 48t plus 160, where h is again height in feet and t is time in seconds. What is the maximum height the rocket reaches? So again, let's draw a picture of this. Again, height and then time. So we should be focusing on just the first quadrant because we're not going underneath the ground and we can't go in negative time. So we have time as our x-axis and height as our y-axis. It's starting, the rocket's being launched from a 160-foot cliff, and you can see on our standard form our y-intercept is 160. So it's already starting here. So this is 160 feet. But then it's being launched upwards, and we know that it will come back down. So the path of the rocket is going up, and then we know it's going to come back down. And it'll hit the ground somewhere. So the question is, what is the maximum height the rocket reaches? So what is the maximum height? So again, we want the maximum, which we remember is the vertex, which is an x and a y. So we want the maximum, but we want the height. The height is on the y-axis, so we actually want the y value of our vertex. So write the equation you are trying to solve. What does that mean? In order for us to find the vertex, we have to find the axis of symmetry and then plug it in. So we find our AOS. AOS is equal to negative b over 2a is equal to our x. And then we're going to plug the AOS into our equation. Into y equals negative 16x squared plus 48x plus 160. Because we're going to be using x's for our AOS, and then we're going to plug it in to find our y value. So let's answer that question. So our AOS, x equals negative b, which is 48, over 2a, which is negative 16. So that's negative 48 divided by negative 32. So we have negative 48 divided by negative 32 is equal to a positive 1.5. And now we want to find our vertex, which x is equal to a positive 1.5, and our y is equal to, going to be negative 16, 1.5 squared, plus 48 times 1.5 plus 160. So if we use our calculator for that, I'm just going to plug that into my calculator to get a value. So we have negative 16 parentheses 1.5 squared plus 48 parentheses 1.5 and then plus 160. We get 196. So this is equal to 196. Now again, the question was asking what is the maximum height. So the question, we're really just asking for the vertex, the y value of the vertex, not the x, just the y. We had to find the x to find the y, but so our answer to answer the question is the rocket reaches a maximum height of 196 feet. It's starting at 160 already, and then it's going up, and then it's going to come back down. Now, it's probably not a professional rocket. It might just be a rocket that for a class assignment or something. but it's not going up very high, and then it's coming back down. So it's reaching a maximum height of 196 feet, and then it's coming back down. So we answered the question of what is the maximum height. In order to answer that question, we had to find the AOS to be able to plug it in. But the maximum height is just 196 feet.